Math 7, Unit 7, Lesson 6, Part 1. Lesson 6, Part 2 will be coming out Monday. I will not be posting a lesson tomorrow on Friday. It's fundamental counting principle. The set of all possible outcomes of one or more events is called a sample space. All right, we're getting into compound probability here soon, where we'll be looking at multiple events taking place rather than just one. You can use tables or tree diagrams to find the sample space of two or more events. So here's an example of a table. Now on a table, along the x-axis I've put event 1, and it can happen 3 ways. Event 2 can happen 2 ways. And that gives us a total of 6 different ways that the 2 events can occur. We could have event A or event 1 happen in way A, way B, or way C, while event 2 is happening in way 1. And then it can also, if event 2 happens in way number 2, you have event 1 that can still happen in A, B, or C. So there are those 6 options. We can see the same thing with a tree diagram. Event 1 happens the 3 ways. The tree diagram looks like what's sometimes called a decision tree, where each time you make a decision, you go down a different branch of the tree. And the total number of, where the branches come all the way out the end, kind of the end decisions, that gives you all possible options. Now, a list of those possible options is called a sample space. And that's exactly what a sample space is. It's the set of all possible outcomes for one or more events. And a table and a tree diagram are 2 really good examples for how that can be done. Now, if it's 2 events, a table works very well. For 3 events, you'd have to make a 3-dimensional table. That'd be kind of hard to do, or make multiple tables. Not very good for 3 or more events. But tree diagrams, they can keep breaking down as far as you have room to. So we're going to be using one of the papers out of your assignment packet on being able to do tree diagrams. See, at the top it's just called counting outcomes. Okay, all right. You may have to pause and slow this thing down because it's a video. I've done some things to make it go more quickly. So when we consider 2 coins getting tossed, we are going to do all of these using a tree diagram. You can see the first coin, I have 2 outcomes. It could either come out heads or tails. Now after I do that first coin, I'm going to have to do the second one, and it can come out heads or tails as well. And this gives us the sample space of heads, 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 tails, tails, heads, and tails, tails. There are 4 total outcomes when flipping 2 coins. Let's look at the next example. By the way, again, you can pause and rewind and look at these more closely if you need to. A coin is tossed and a number cube is rolled. Well, our first situation here is flipping and getting heads or getting tails. Let me scroll down here. Maybe I will. Oh, my mouse is not turned on. Okay, so we get heads or tails. And then after that, we're going to roll the number cube. And it doesn't matter whether we rolled heads or tails. We do get just 6 options for the next thing. This gives us a total of 12 outcomes. We could get heads in 1, heads in 2, heads 3, heads 4, heads 5, heads 6. Or we could get tails 1, tails 2, tails 3, tails 4, tails 5, or tails 6. Total of 12 different outcomes. Remember that the name of this list is called a sample space. That is the sample space. Okay, Sam's Sunday Shop is having a Sunday special. For $3, you may choose 1 flavor of ice cream, 1 sauce, and 1 topping. Sam's ice cream flavors include vanilla, chocolate, strawberry, mint, and Oreo. That's 5 flavors. He has raspberry, pineapple, and chocolate sauces. That's 3 different sauces. The toppings include nuts, sprinkles, M&Ms, and chocolate chips. How many different $3 sundaes can Sam make? All right, first consider there are 5 options for the ice cream flavor. So the first decision would be to pick an ice cream flavor. After that, we need to pick a sauce. Now, there are 3 sauce options after you've selected the ice cream flavor. You'll either get raspberry, pineapple, or chocolate. And then after that, we've got one more decision. We decide on the topping, which can be nuts, sprinkles, M&Ms, or chocolate chips. Now, there are a lot of outcomes here. I need to scroll up a little bit. It looks like 1, 2, 3, 4, 5, 6, 7, 8. Oh wait, I can count by 4s, can't I? 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52. Keep going down. 58, or 56, 60. There are a total of 60 outcomes, or 60, I guess in this case you could call them sundaes. There are 60 sundaes that you could pick from at that Sam's Sunday shop? Yeah, at Sam's Sunday shop. And the list of those, it would be a rather exhaustive list because the first one on the list, a vanilla with raspberry sauce and nuts. Then the next, vanilla, raspberry sauce, and sprinkles, etc. till you get a whole list of 60 of them. That's a lot of options. Next, when ordering a new Ford Ranger pickup, the customer will need to decide the basic package by choosing a color from black, red, blue, green, or white. She will also need to decide if she wants an automatic or manual transmission, and whether or not she wants 4-wheel or 2-wheel drive. Finally, she'll need to decide if she wants it regular or an extended cab. How many different basic packages are available for the Ford Ranger? Wow, there's a lot going on this one. So let's just underline some things that are going to be important here. We've got color, which is black, red, blue, green, or white. We've got transmission, which is automatic or manual. We've got drive, which is either 2 or 4. And finally we have cab, which is either regular or extended. So the first decision here would be on the color. Okay, scrolling down a little bit so we can see a little bit more of this. After we've decided on the color, you make your next decision, which I believe was the transmission. So this will go off to being either an automatic transmission or a manual transmission. After that, we need to drivetrain, either 2-wheel drive or 4-wheel drive. And after, come on, there we go. And there's one more, the cab, the extended cab or the regular cab. So that gives us a lot of options here. I think if you were to count those up, this does come out to be 40 outcomes. Now, dealerships usually do not keep all of these in stock. That would be 40 different Ford Rangers. Unless it's an extremely large dealership, they'll keep some of the popular ones in stock. And if you are buying a new vehicle, you can usually go in and order what you want. The color, the cab, the drivetrain, maybe even getting some custom things. That, as long as you're willing to pay for it, you can get a lot of things. Okay, let's take a look in general here. When I flip 2 coins, the first coin has 2 ways that it can, 2 outcomes. The second coin has 2 outcomes, and the total number of outcomes was 4. On the second one, the coin had 2 outcomes, the die roll had 6 outcomes, and there were a total of 12 outcomes in the sample space. The third one, there were 5 ice creams, 3 sauces, 4 toppings, and a total of 60 different outcomes. For the vehicle, there were 5 colors, 2 transmissions, 2 axles, and 2 cabs. And there ended up being a total of 40 different models of the truck that you could get. So For problem 1, list the number of possibilities for each event and the total outcomes. Then for problem 2, 3, and 4, got that done. Find a relation between the numbers of the events and the total number of outcomes for each problem. Write your discovery here. What you should notice is that 2 times 2 equals 4, 2 times 6 equals 12, 5 times 3 times 4 equals 60, and 5 times 2 times 2 times 2 equals 40. This is the fundamental counting principle. Each event has a certain number of outcomes, and if multiple events happen, you can find out the total number of outcomes for the compound events by multiplying the number of events, or the number of outcomes for each event together. Okay, so with that, we just introduced the fundamental counting principle, which pretty much the total number of outcomes equals the outcomes of event 1 times the outcomes of event 2 times the outcomes of event 3, etc. That's basically the fundamental counting principle. Okay, I recommend you pause the video at this point and practice the attached worksheet, or you can do one at a time. Watch the video to see if you did it right. Use this kind of as a guided practice thing. Okay, getting right into it. Use the fundamental counting principle to find the total number of outcomes in each situation. Tossing a quarter, a dime, and a nickel. Okay, if you toss a quarter, there are 2 outcomes, specifically heads and tails. If you toss a dime, there are also 2 outcomes, heads and tails. And if you toss the nickel, there are 2 outcomes, heads and tails. That's 8 total outcomes for tossing 3 coins. Now, that's a short enough list, I could actually quickly create it. It'd be heads, 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 tails, heads, tails, heads, heads, tails, tails, and tails, heads, 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 tails, 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 heads, and tails, tails, tails. Those are all 8 outcomes in the sample space for tossing a quarter, a dime, and a nickel. Okay, choosing scrambled, sunny side up, or poached eggs with bacon or sausage and milk or orange juice. Okay, first we've got 3 types of eggs, 2 types of meat, and 2 types of beverage. Wait, I wrote the wrong number there. There were only 2 types of meat and 2 different beverage options. This gives you a total of 12 different breakfasts. Okay, and I could list those, but I'm not going to. Choosing a number on a number cube and picking a marble from the bag at the right. Well, there are 6 outcomes on a number cube. There are 1, 2, 3, 4 marbles in that bag. Well, they're actually not in the bag, but they're out of the bag so that we can see what they are. So 6 times 4, that is 24 outcomes here. Number 4. Beth has 3 sweaters, 4 blouses, and 6 skirts that coordinate. Oh, so there's nothing mismatched. That's nice. Find the number of different outfits consisting of a sweater, blouse, skirt that are possible. Okay. Then find the probability of randomly selecting a particular sweater, blouse, skirt, outfit. All right. So we're going to do the fundamental counting principle, and then we will calculate the probability just using simple probability. The fundamental counting principle will give us the total number of outcomes. And one specific sweater, blouse, skirt, outfit, that is only one of those outcomes. So we start with 3 sweaters. we have 4 blouses to pick from and 6 skirts to pick from. This gives us a total of 72 different outfit combinations that could happen. So the probability of selecting a particular, just one of them, sweater, blouse, skirt, outfit, is one outfit out of the 72 possible outfits. It would have a probability of 1 out of 72, 1/72. Number 5, choosing a bagel with one type of cream cheese from the list shown in the table. So a bagel and a type of cream cheese. Well, from the bagels, we've got 1, 2, 3, 4 options. And the cream cheese, there are 3 options. That gives us a total of 12 bagel. I'm going to just call it bagel snacks. There are a total of 12 different bagel options. Number 6, choosing a number from 1 to 20 and a color from 7 colors. All right, there are 20 outcomes in the numbers 1 through 20. There are 7 colors. This gives us a total of 140 outcomes. Okay, number 7, picking a month of the year and a day of the week. All right, month of the year, there are 12 of them. Day of the week, there are 7. So there's 12 months times 7 days of the week. This gives us 84 combinations. Now let's just call it outcomes. Okay. Number 8, choosing from a comedy, horror, or action movie, each shown in 4 theaters. All right, we have 3 different movie genres and 4 theaters. That gives us 12 outcomes. Now maybe I could call these 12 dates if you're going to a movie at one of 4 different theaters on a date, but we'll just call them outcomes. Rolling a number cube and tossing 2 coins. All right, rolling the number cube, since it's a cube, it has 6 outcomes. Tossing 2 coins, the first coin has 2 ways it can land, heads or tails. The second coin has 2 ways it can land, heads or tails, giving us a total of 24 outcomes. Number 10, choosing iced tea in regular raspberry, lemon, or peach flavors. That's 1, 2, 3, 4 options. Sweetened or unsweetened, that's 2 options for that. And in a glass or plastic container, that's 2 options. So we have 4 options for the flavor of iced tea, 2 options for how it is sweetened or not, and 2 options for the container. This gives us a total of 16 beverages. 16 different iced teas that we could get. Okay. Oh, did it just skip from 10 all the way to 14? It apparently did. Find the number of possible choices for a 2-digit password that is greater than 19. Then find the number of possible choices for a 4-digit personal identification number, PIN, if the digits cannot be repeated. Oh, we're going to have to do some extra thinking here. Because if it's a 2-digit password bigger than 19, find the number of possible choices. Okay, 2-digit password greater than 19. Well, that's just going to be the numbers 20 through 99, right? How many is that? That's just, 99 minus 20, right? That would be 79. Plus we have to add on 1 because we didn't include 20. So that's actually 80 options. Another way to look at that one is for the first digit. This might be a little bit better way to look at it. The first digit has only 8 options. It can be a 2, a 3, a 4, 5, 6, 7, 8, or 9. That's 1, 2, 3, 4, 5, 6, 7, 8 options. The second digit can be anything between 0 and 9. There are 10 of those. This gives a total of 10 passcodes or passwords. By the way, a 2-digit password is extremely unsecure. If there were only 80 things to choose from, someone wouldn't have to be very vigilant. They can sit down and guess 80 passcodes in a matter of a couple of minutes. And that's at human speed. A computer can do it in less than a second. All right, then find the number of possible choices for a 4-digit personal identification numbers if the digits cannot be repeated. Now this cannot be repeated makes things a little bit difficult. If they could be repeated, that's great. We just have 10 each time for the 4 digits, giving us 10,000 options. However, they can't be repeated. Now for the first digit, I can't repeat, but nothing's happened yet. I have 10 options. For the second digit, I have already used one of my digits. It does not matter which one I've used. There are only 9 left that I can use now. For the next digit, there are only 8 left because I've already used 2 of the digits out of the 10. And for the last digit, there are only 7 digits left. I have already used the other 3. So the total number of 4-digit PIN codes where the number cannot be repeated will be 10 times 9 times 8 times 7, which is 5,040 passcodes, 5,040 PIN numbers. I'm just going to call it 5,040 pins. Okay, number 15. A store advertises that they have a different t-shirt for each day of the year. The store offers 32 different t-shirt designs and 11 choices of color. Is the advertisement true? Okay, we've got 32 t-shirt designs, and we're going to multiply that by the 11 choices of color, and we get 352. Now, do they have one for each day of the year? Well, you have to pull out of your memory how many days there are in a year. There are 366 days this year, 365 in a normal year. But since it's leap year, it's kind of an odd year. Well, odd year, but it's an even number of days. Anyway, is their advertisement correct that they have a different outfit for every day of the year? No, it is not. And my explanation would be 352 is not bigger than 365. I'm going to go with a regular year, not necessarily this year. This year has been rather strange, as you all know. So, but if we think of a regular year, it still wouldn't be in a regular year. Okay, plan on Monday getting the second part to this lesson, and you'll do probability.5 on Monday after that lesson. Thanks for watching.